Hey, everybody. It must be 2 hours UTC because it is time for Astronomy Daily Live. Hey, hope everybody's doing good tonight. Hope everybody had a great day. It's a nice, relatively calm day around here. Nice, clear skies, a little bit of wind, but nice, clear skies. So yeah, hope everybody's doing well. Glad you're stopping in, either live now or recorded later. Either one. Glad you could come in. This is just, it's a circle of friends who gather together every single day to talk astronomy. And topics can be pretty much anything, that the group wants. Uh, we can probably easily deliver. So yeah, come on in. I'll stall a little bit here to let people trickle in a little bit. This is just a casual um, gathering of friends, but at the same time, I'm extremely um, skeptical yet open-minded about pretty much anything related to science and technology and all of that. But this is primarily just an astronomy live stream happening every day, every single day, same time, usually the same place at 2 hours UTC. So yeah, glad you could join in. Um, Pretty much uh, open topic here, but we can do Q&A if you have any kinds of questions in terms of astronomy that yeah, you're just dying to ask, and I'm trying to get an answer to. Uh, Definitely won't claim to have any definitive answers, but I can definitely tell you the knowledge I have, and if nothing else, maybe point you in a direction that will lead you to an answer that you are looking for. So yeah, glad you could come in. I'm gonna go get a kitty. Hold on. Come on. Out of there. Out. Out. Kitty's always causing trouble. So I've got the usual poison tonight. It's a nice calm evening, so I'm not getting too excited about things. And tonight's chemical of choice is the hydrogen hydroxide. So cheers. Mm. Yep, awesome. So yeah, I just got off the live stream, Deep Astronomy's live stream with Tony, talking about his contest, and I don't get too enthused about contests, but it is an interesting problem that he is um, trying to find, and it's definitely uh, um, uh, sort of a hole in the implementation of the worldwide telescope. So, and it seems strange to me that Hubble images aren't being included. Hmm, that would seem to me to almost be the first place to go for that kind of thing. So, uh, but the fact that a problem has been identified, and at least it looks like Judy has cleared a path cleared a path to the solution. It's yeah, that's not a huge pain, but if one wants to eventually uh, put in thousands and thousands of these um, um, images, you definitely don't want to have to do that in a manual way, and go through all the manual steps that that seems to do. There's a great program, and I don't think I don't know if there's a Windows or Mac version of this, but there is a Linux version of this. It's called FFmpeg, and the name sort of is a deceptive thing. This program is absolutely mind-blowingly awesome. It's it has quickly risen uh, in my realm to be sort of a go-to. Um, I don't even know how to describe it, but what I'll do is on my Linux machine, I'll look at the man page, which is a manual page. It's just a manual for that function. So if I do man ffmpeg, so what it calls itself is a video converter, but let me tell you, it is so much more. It is so much more. This can convert pretty much any format to pretty much anything else. And when I say format, I mean video, audio, or image. The only thing that I don't think it does, I guess I've never looked into this extremely hard, I don't think it deals with fits. I don't think it deals with fits. But maybe it does. Maybe it does. Yeah, I haven't really pushed that too far yet. I know that at least at first glance, there isn't a fits output. So maybe not. It might be able to be used, but I mean, what I see as a solution is like a script, some kind of like a shell script, or maybe like a Perl or um, um, Python program that can has various output, various um, inputs, and you tell it, okay, I want to put this image from like the HST archive into worldwide telescope, and you provide it like the URL to the HST fits image, and then internally in the script it sort of does everything else. It actually goes and grabs the fits image. If it has to decompress it, it'll do that, and then it has to go through all this thing about adding the metadata to eventually, I guess, a TIFF file. It seems as though, at least how Judy was explaining it, that the Worldwide Telescope wants a TIFF image. Maybe I misinterpreted that. Misinterpreted that. Don't know. But yeah, as I said, I'm not much into contests, and this is a easy way to get sort of some free labor done, to solve a problem, but in the end, those who solve the problem, get the credit. They get the gold star, and that makes everything better. So hey, I am all for it. I'm all for it, and yeah, I'll definitely look into it a little bit more. What I'll do probably right after this stream is I'll go back through Judy's tutorial on just going through all of the steps. I'm going to have to download or download, I guess, the worldwide telescope client program. So it's running on my local machine. I hope they have a Linux version of that. Oh, what I'm going to do is I'm going to load up my. Already started. I don't understand why this happens, and if somebody can explain it at some point, I would absolutely love it. But why do only live streams freeze my Linux machine? It's a mystery to me. It's a total mystery. Yeah, he's giving away T-shirts and all that too. That's just a little bit of enticement, because he wants to give back, and I understand that too. But yeah, I guess in this case, we just want to do it for the fame. So, but fame costs, right? And right here is where you start paying in sweat. so yeah. But I think, as I said, Judy in very, very, very quickly sort of cleared the path, and so yeah, solution is right around the corner. But what I'm thinking in my head is some kind of a script that takes some basic input, or maybe like a parameter file or something, and goes grabs the data, extracts the header information, puts it into the right place, and then loads it onto the WWT, and you're done. So yeah, I think that probably can be done. But yeah, I'm going to run through the tutorial. And hey there, Uncle Bill. Nice hand waving there. So yeah, I'll go through her steps, to make sure that I can load it in as well. It seems a little strange that anybody can load sort of anything onto the worldwide telescope. I don't quite understand. Yeah, I don't quite understand that, how that can be done. I mean, what if it's like completely wrong, or yeah, I'm not exactly sure how that works. So but yeah, I'll figure that out too. Hey there, Tom. Hey there, Uncle Bill. Nice you could come by. Good. I'm glad they have MPEG for Mac. So yeah, it's an amazing piece of software. I'm sort of beginning to liken it to GNU-plot. That's this extremely powerful piece of software that I just barely scratch at. MPEG is sort of the same way. I sort of just scratch the surface of that thing. There's video encodings and formats and it's too much. It's just a lot of stuff that is packed into this little small short named program, right? That's sort of you know, not even um, um, not even really descriptive of on what it does. Probably, you know, I mean, usually what happens is that, you know, a program like that is written for a particular thing, and it gets a name, and then they start adding things, and you know, the name just stays exactly the same because, you know, it's probably in a make file, and you know, you're just not going to change the name every time you add some functionality to it. So, you know, but yeah, it's a big program. It does a lot of shit, a lot of cool shit. So Uncle Bill's asking, are they adding to the online database or their local copies? Oh, okay. Yeah, maybe it's just adding to a local copy. You're exactly right, because I think in order to sort of get the what do you want to say, full feature WWT, it runs as a client program on your local machine. That's my understanding. So yeah, maybe it's just a local thing. So that makes a lot more sense. Um, that, you know, the WWT would, and yeah, you know, now that I'm thinking about it a little bit more, it's like, okay, you know, there are things, you know, I mean, when you load up your client, you still get images, but those images are coming from the server. And then if you want to add anything, that would be on your machine or, you know, the client. So yeah, that's starting to make a little bit of sense. So okay, well, cool. Anyway, I'm going to run through that, and because yeah, I sort of have to catch up to Judy. You know, she sort of uh, grabbed the baton and ran. So you know, uh, I sort of just was like, okay, look, I'm not even going to run. I'm not even going to. I'm not really even going to try, because she has taken the baton and cleared a path for, you know, the rest of us now. So awesome. Um, so yeah, I think at least as far as I'm concerned, I'm sort of looking at a script of some sort, you know, that can do this kind of thing. And a script is just a list of commands or programs that can be executed inside of um, some kind of a shell, uh, either on a Windows machine, or definitely, you know, like on a Unix based machine like Linux. So yeah, that's sort of the direction I'm going to go, and yeah, we'll sort of see where that goes. I guess the end game is to convince the WWT folks to sort of incorporate this process into what's happening on the server, um, and that's where, you know, all the credits and the gold stars and everything are sort of doled out. So yeah, you know, it's not necessarily a gripe, but yeah, you know, it's um, uh, sort of a means, you know, to get free labor out of us, and but I'm smiling, so can't be all that bad. So yeah, awesome. It's always really exciting to find, you know, uh, uh, some kind of hole that needs to be filled, and Tony, you know, hats off, because you definitely found a hole that strangely enough I would have thought would already have been filled, because that seems like sort of a no-brainer to me, to want to incorporate Hubble images into the Worldwide Telescope. But it looks like they're using um, digital sky survey images, which is old shit. This is old, crappy stuff. Visible light, and that's it. It's like, come on, come on. So, I don't know anything about WWT at all. So, I mean, I assume that you can also include um, X-ray, um, radio wave, submillimeter, infrared, uh, other wavelengths into this, and I'm wondering if there are similar holes that need to be filled. Don't know. I, I, I was watching the latest lecture from CFA. That's over at Harvard Center for. Oh, I don't know what CFA stands for. I don't remember. What does it stand for? Let's find out. CFA. Sometimes the old brain just doesn't click. Doesn't click. Center for Astrophysics, is that it? Center for Astrophysics? Something like that. Harvard. CFA Harvard. Why is it taking so long to load? Probably because I'm streaming. Center. So CFA .harvard.edu. Actually, www.cfa.harvard.edu is the Harvard Smithsonian Center for Astrophysics. So they have a talk that they put out on a YouTube channel, and this week's talk, or this month's talk, was on the status of the virtual observatory, which I heard about the rumblings of that back in the late 90s. Everybody was really excited about that, and I guess it's been going through sort of a rough time. Everybody thought it was dead, and yeah, actually, from the talk, it seems more like a bureaucracy than anything else. But I guess the idea with the virtual observatory now is to sort of set standards, standards for data, specifically metadata. So the data that describes the data. Cheers. So the virtual observatory doesn't seem to be dead, but it's sort of changed into sort of a committee that establishes standards. So yeah, that's all right. Basically the idea there is that if an institution wants to be part of the virtual observatory and they want to plug in to it, then they have to provide the plug-in. So a virtual observatory says, okay, these are the standards that we have, and so some kind of institution that wants to be a node of that has to in some way modify the metadata that they have for their data in order to communicate with the virtual observatory interface. So once they do that, then anybody entering the virtual observatory can access that data, and it's sort of a uniform, easy thing. And they tried to give a demonstration of that during the talk, and that was, you know, live demonstrations are really hard, because you will sit there, right, for 2 hours beforehand, and you will practice it, and you'll run it, and it'll you'll fine tune it, right? You'll get it just running perfect, right? Everything's great. You run through it over, what you're going to show. You run through that over and over and over again, right? To make sure that it all works, right? And then everybody comes in, they sit down, you start your presentation, you sort of hit the run button, and it all breaks. So it wasn't quite that extreme in this case, but it was running really slow, and there were some features that he wasn't able to pull out, and yeah, it's just the usual stuff. So that's no problem at all. You basically get the idea, and in that case, what you do is you just do some really slick talking, and you just explain. You try to explain in words what you should be seeing going on up on the screen. I'm going to go back to the chat here because I got off of that. Okay. The other thing that I keep forgetting to mention is that I have a Discord server as well, and a link to that is down in the description. I'm going to go over to the Discord channel on my laptop here. This laptop is also the machine that I'm using to do the Google Hangout with this camera. That for some reason, and I'm sort of going to get into this too, I think we'll do an object of the day as well. We'll stick with the Messier catalog for now, but I'm just going to go over to my Discord server, and over there I've got a number of channels on my server. I've got one for this stream, so if you want to chat about this stream over there, that's sort of why I'm going over there now, is because I want to make sure that I'm not missing any of the action over there. It doesn't look like I am. But I also have some channels to talk about space and talk about science, talk about art, technology, and any kind of miscellaneous things. I'm still working on my audio. What I want to be able to do, and I just haven't sort of gotten around to looking into it any more. Maybe this weekend I'll look at this a little bit harder, but I want to be able to pipe the audio from my Discord server into Google Hangouts, right? So you guys can not only hear me, but you can hear anybody who wants to do the audio on Discord. I want to get Uncle Bill in here to talk about Cow Sky, because Cow Sky looks really awesome, and I've just sort of glanced at it, but yeah, I'd like to get somebody experienced with it, to come in here and sort of walk me through it, walk us through it, because yeah, it looks like an interesting resource. And Uncle Bill claims to well, I don't think he claims to be an expert or anything, but at least he's a user, and so he knows his way around a little bit with that. So yeah, so last night, I don't know if you caught that or not, but I did a live stream of the first quarter moon last night. So look, I'm going to go back to my looking at the thing just to make sure that I'm not slouching too much or out of screen. But yeah, so I did the first of many um, um, uh, uh, data collection things for measuring the distance to the moon, and I and two others who I contacted a couple weeks ago uh, did actually take some pictures of the moon next to the star Aldebaran, and they have um, sent their pictures to me. So I have mine and I have theirs. So now it's up to me to sort of go through the images, make the measurements, um, plug them into, uh, just some simple math and calculate the distance to the moon and see what we get. So a user who stumbles, yeah. Hey, you're part of a big crowd. I'm part of that too. But yeah, so right after, and actually right during I was doing that, I also began a live stream looking at the moon, and learned a lesson there. Learned a lesson for sure, and that is, if I want to live stream, I definitely want to do all the um, um, star alignments and everything with the scope before I start the live stream, because those poor folks suffered through like 24 minutes of just black screen while I was finishing taking pictures of the moon and the star with my smartphone, and then spending 15 minutes trying trying to rapidly do a star line where and you can't see it here, but I have a finder scope sort of on the opposite side of the scope here, and usually um, that little scope has a little light in it that puts a pinpoint red dot right in the center of its field of view, and that allows me to line it up and be able to point to things with the main scope, because the finder scope and the main scope are co-aligned. And so if I center the object that I'm trying to find in the little finder scope, then it should be centered or relatively close in the main scope. And without that little red dot, it's really hard to know where the center of the field of view is of the finder scope. And so I was having to try to guess, and it's just really hard. It's really hard. So I need to get a new battery for that. What happened is is that the last time I used it out, I just left it on, right? Left it on, battery goes dead, no light, makes it really hard to line things up. So what I ended up doing is just um, uh, not aligning the telescope, which means that the telescope did not track at all. So I had to be very active, which I don't mind. I had to be really active in keeping the moon in the field of view, and the field of view is so small anyway, which sort of means that the magnification is so high that the motion is really fast. The Earth spins really fast. If you didn't know that, at the equator, person standing on the surface of the Earth is traveling about 1,000 miles an hour. So that's just insanely fast, and you sort of wonder, it's like, why don't I feel that? You know, why don't I spin off and all that? Well, if you do the math, and I did, and I don't have the numbers in my head, but the gravitational pull on you is orders of magnitude stronger than the centrifugal force. So it's hard to imagine, because you are essentially attached to a string that is attached to, you know, the center of the Earth, and that string is being spun around at 1,000 miles an hour. So you would think that you know, the centrifugal force would throw you off, right? Completely throw you off. But it turns out that, you know, the gravitational pull on you, so-called gravitational pull on you, is actually, you know, orders of magnitude, as I recall, stronger than that. So you know, you're not going to fly off. It's like, well, why don't we feel it? Well, two two primary reasons, I guess. The first is that it's really, really smooth, right? There's no friction at all, so it's super, super, super smooth. And I think that we're just used to it. It, it it's the kind of motion that we have been experiencing, uh, you know, before we were born, and we're experiencing it now, and we're just really used to it. It's sort of like, you know, uh, I'm walking into a room that has a bunch of smells, right? And um, once you're in there for, you know, like an hour or two, you don't smell anything anymore. So it's sort of like that, I think. So yeah, it's pretty amazing. A lot of motion. But what I wanted to do was just sort of show you what I took. About 5 minutes worth of data last night. So I took a video, you know, just a recording of that, and I put it on. I think I put it on my thumb drive here. So I'm gonna eject my thumb drive from my Linux machine. Da 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 da. Oh, it says don't unplug until finished. Okay, there it goes. These, if you didn't know this, you don't necessarily have to wait for these things to say that it's okay to pull them out. These are solid state, so you're not going to break anything. You're not going to destroy anything if you just pull them out. You don't necessarily have to unmount them or eject them or anything. It's always a good idea to do that, but yeah, you know, don't think you have to. I heard something in the Discord channel. What did I hear in the Discord channel? Oh, it must have been something else. Yeah, must have been something else. All right, so what I'm going to do is, and I'm just going to show this a little bit because I want to get to our object of the day. Object of the day. But let's look at this. Where did I put it? Maybe I did. Oh, I probably did. Well, let's see if it's in here. Maybe I did a cut and paste. Yeah, looks like I did. All right. Well, while we're doing that, I'm gonna try to get that video on here anyway. Save MV file. And let's see. Okay, so I'm going to put this back on my Linux machine. Back on the Linux machine. While I'm doing that, I'm going to share my screen. Share my screen. Go to Infinity. We're going to go over to random.org. And over on my Linux machine, I'm going to Look over to the moon. That would no, not moon. Where did I put it? I don't even remember where I put it. Where did I put it? Let me look and see where I even put that video. I don't even remember where I did that. That's horrible. So many things get incredibly lost. Now that says that it's still on my thumb drive. Let's see. I don't see it there anymore. Oh, I moved it. Ah, okay. All right. I see where it is. I did put it here. Strangely enough. Oh, yeah, of course. Of course, that's right. All right. I'm going to put you down. Well, no, I don't have to. I can copy it over. I can do this one-handed. No problem. It's kind of hard to see with that in the way. Whoop. Okay, so I'm copying it over there. Dun, 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 dun. While we're doing that, let's look. So I'm going to do the Messier catalog again. So there's 110 Messier objects going from, of course, 1 to 110. And okay. So now I'm copied the video back over to my thumb drive. Dun, 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 dun. Sing a little song. I don't know why that's not loading up. Here it goes. Thinking about it. Dun, 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 dun. Okay, so there it is. So I'll just play a little bit of this just for fun. Let's see, media player. And do it. VLC is my media player of choice. Hide. See if it comes up here. So what I'm going to do is I'm going to use FFmpeg to extract all of these frames, and maybe even not all these frames, but I'll run this for a little bit, and so you can just sort of see. Mute that. So you can just sort of see what I was up against last night, see what you missed. Just the moon, you know. But yeah, I was scanning around, and then that motion there, the motion sort of to the bottom right, when everything is moving to the bottom right, that's the actual motion of the Earth. Everything else is me sort of scanning around, playing with the focus. But yeah, not too bad. Not too bad. But as you can see, it's a really, really, really small field of view. So I want to get a thing called a focal reducer, and that will double the width of this field of view, so it'll increase the area by a factor of 4. But yeah, that's still not too bad, you know. Not too bad for a little webcam. These are I think they're 12. Does it say? I think it's like 1280 by 720, something like that. So, you know, not too bad. There's the edge of the moon there, looking kind of cool. So yeah, that was, I'm not going to do that much because, you know, just doing a live stream looking at the moon, yeah, I don't know if that's extremely interesting. It's not a huge effort, you know, to do it because I just have to walk outside. Um, but yeah, you know, it's probably not incredibly interesting or anything. I think once I get the focal reducer on there, I can maybe do a little bit more, have a little bit wider field of view, be able to pull in some things that aren't the moon, right, and aren't necessarily planets, but more like, you know, some brighter deep sky objects like the Messier objects. So let's go over to that. So we're going to go over to random.org. I'm going to take a big swig of this chemical called hydrogen hydroxide. Cheers. And we're going to have random.org choose our Messier object of the day. Okay, so I always think that we need a drum roll here. So generate. Here we go. 3, 2, 1, bang. M71. Ah, M71 is one of my favorites. It is probably, gotta say, M71 is probably my second favorite Messier object in the whole catalog. It's a very, very rich open cluster. It's near the constellation of Sagitta. I don't know if it's actually in the constellation of Sagitta, but I want to say that it is. So let's go over here. Let's go to Sinbad. Let's just go straight to Sinbad, all right? Sinbad is an astronomical database that has information on pretty much everything. So let's go M71. Oh, it's so exciting to have this object. Oh, okay. They're calling it a globular. Yeah, okay. It's the globular that is over in Sagitta. Not an open cluster. It's a globular cluster. So just like yesterday's was also a globular called M92. This is M71. And again, it's all the same basic information that you've seen a few times now. First three numbers here are the right ascension. Right ascension in the sky is sort of like the east-west position. So it's sort of like the longitude. And right ascension goes from 0 hours all the way around the celestial sphere from west to east, going from 0 hours to 24 hours. So the 360-degree sphere, celestial sphere, is divided up into 24 chunks, which are actual time. So you know, the since in one day, the entire sky will go around 360 degrees. That's also 24 hours, right? One day is 24 hours, which is also 360 degrees. So in 1 hour of time, the sky rotates by 15 degrees. Hope that makes sense. That's just 360 degrees divided by 24 equals 15 degrees. So that's a way for you to figure out actually what time of day it is, what local time of day it is. Because if you can see the sun and you know which way north is, then you can pretty accurately actually determine what time it is, because you know that the north-south line, which is called the meridian, that north-south line basically defines noon, right? Noon local time. That's when the sun crosses on the meridian. So you can look at the position of the sun relative to this north-south line, and if it's east of this line, then you know at least it's in the morning, and if it's west of this line, you know that it's in the afternoon. And then you can sort of guess as to how many degrees away the sun is from the meridian. And you know that from the horizon to the meridian is 90 degrees. And strangely enough, 90 divided by 15 is 6. So it takes approximately 6 hours for the sun to go from the horizon, which would be sunrise, up to the meridian, which is noon, and then another 6 hours approximately to go from noon to the western horizon. Now, depending on your latitude, that time changes a little bit, but that's approximately. So yeah, if you know which way north is and you can see the sun, then you can make a pretty good guess as to what time it is. And I learned this years ago, and so I do that all the time. So I naturally don't wear a watch anyway. But if I need to know the approximate time quick, I just look up in the sky and I find the sun, and it's like, oh, okay, it's about 10 a.m. Or whatever it is. So that's, yeah, I sort of went on a tangent there, but the basic idea is that the right ascension is sort of your east-west position, analogous to longitude. And so these next three numbers, 18, 46, 45.1, that's your declination, and that is sort of like the latitude, right? So there's that. Here are the galactic coordinates. So relative to the plane of the galaxy, that's where the same object is. It's also coming towards us at a velocity of 16.9 kilometers per second. Now, M92, as I recall yesterday, was like 2.8 by 2.8 arc minutes. So M71 is a little bigger. It's also a little bit fainter. I don't remember now what M92. No, M92 I think was like 6.5 V magnitude. This is 6.1. So 6.1 is a little brighter than 6.4. The magnitude scale in astronomy is sort of backwards. So the larger the number, the fainter it is. I'm going to go over to my Discord because I'm hearing Uncle Bill. He posted a awesome picture of M71. Yay, very cool. Yeah, one of my favorites. I was thinking of something else. So it wasn't M71 that's my top top two. There's another one over there. There's another one over there that it's an open cluster. I thought it was an M70 something. Don't know. Let's stick with M71 for now. So this is kind of neat to see. This interactive view here usually comes up highly magnified. Let's see if it does again. Yeah, highly magnified. So we can zoom out a little bit and sort of look around the area. Now, what you'll notice, if you remember, M92 was sort of in a pretty sparse area of the sky. There weren't a lot of stars. Look at this. Look at all of these. And the reason why is because we are looking basically through the plane of our galaxy. And so we're looking through a lot of stars before we actually come to M71. M71 most likely is sort of behind all of these other stars. Isn't that amazing? Or maybe in the midst of them. Kind of hard to tell, without knowing the distances to all these stars. We don't really know where it is. But this, again, is an object called a globular cluster. And it's just a cluster of stars, pretty old stars, most of them, all gravitationally bound. So it's like this swarm of bees just buzzing around each other. But in this case, every single bee is a star. So yeah, that's a nice rich cluster there. Lots and lots of stars. As I said, I think this is in the constellation of Sagitta, if I remember right. I'm gonna back out and see if I can identify these bright stars in here. Yeah, so here's sort of the constellation of Sagitta. It's got these two bright stars, and then these two down here sort of mark that. Now, the interesting thing about the constellation of Sagitta, I'm just going to diverge for a second here, because right next door to Sagitta, let me see if I can find it. Right next door to Sagitta is another Messier object. Can I find it? Yeah, I'm gonna have to zoom out a little bit more, I think. I'm really going off on a tangent here. Major tangent. It's probably up here. Let's see if we can find it. This is star hopping at its best. Oh, I'm not seeing the star pattern that I'm expecting to see. Maybe it's this way. Maybe it's this way. Yeah, there it is. So right next to M71, okay, here's M71, this little dude right here, right? Well, look at this. Look at that. This is another Messier object called M27, also known as the Dumbbell Nebula. Let's just zoom in on that, like really quick, just for fun. This is what's called a planetary nebula. Supposedly, this is the remnants of a star that has gone through some kind of explosive event and sort of expelled its atmosphere. And so this is overexposed. In the center of this nebula is what's called a white dwarf star. Can't be seen here. This is overexposed in the middle. But what you're seeing here is just this big ball of really hot gas. And it is slowly expanding. But anyway, that's another Messier object. We did not choose that one. I'm just I'm being the astronomer, and it's like, okay, if we see one Messier object, we have to look at another one. Come on. Let's zoom back into M71 here so we can see that a little better. Anyway, so there it is. Very, very cool. M71. Let's go back to Sinbad now. I'm going to check my chat, my YouTube chat, see how that's doing. Yeah, these are pretty old stars, Tom, for sure. Won't hurt the circuitry, but you want to be sure any files finished moving updated in some cases. You were talking about something, but I was talking about but Uncle Bill, I don't get the context now. Sorry. Let's go down here and see. So it has a bunch of other names as well. So there's M71, but it's also NGC 6838. It's got a few other names as well. Lots of references. Good. 525 of them that between 1998 and 2018. So this object was mentioned in 525 papers, professional papers. There is a measure of distance, so let's take a look at that. It's probably in megaparsecs again. Yeah, 0.004 megaparsecs. It's just ridiculous. So grabbing the handy-dandy calculator that is always, every good scientist has a handy physical calculator on their desk at arm's reach at all times. All times. So a parsec is 3.26 light years, and we're going to multiply that by 1,000,000 because it's a megaparsec. And then we're going to multiply that by 0.004 to get how many light years away it is. So this cluster is 13,040 light years away. 13,040 light years away. So one of the ways to think about that, yeah, happy Friday. Yeah, you know, I took the day off again, Susan, and my brain says it's Saturday, so I'm going to be confused again, but that's okay. So yeah, M71 looks like it's about 13,000 light years away, and one way, you know, to think about that is to say that if you were to go out right now and look at that object, the light that you're seeing from it started from that object 13,000 years ago. So pretty awesome, pretty awesome. That's also a measure of distance as well. So a light year is just how far light travels in a year, and it's approximately like 6 trillion miles. 6 trillion miles. So you know you have to multiply that by 13,000 light years in order to figure out how many miles that actually is. But that's just a shitload of miles. You're not going to get there anytime soon. Let's see. So let's. Is there a Ned? Yeah, there is a Ned. Let's look and see what Ned has to say about Messier 71. Messier 71. So you can see that it gives the same RA, the same deck. It's a cluster. There's some pictures there. There's some spectra. Let's look at the spectra. I'm always into looking at spectra. Oh, there's no spectral data for this object. Wah, wah, wah. Distances. Let's see if there are some additional. All right, I'm not looking too happy about that. Let's see what else we got here. So it's showing it as a few other names. Kind of interesting, right? It looks like 6839, 6838. What's going on there? Don't know. So this is just another way of designating the equatorial coordinates. As I said, 1 hour of RA is 15 degrees east and west, or longitude. See, so 297.884, 297.8845 divided by 15 will give us the right ascension, which is 19 hours, 51 minutes, 32.28 seconds. See how that works? Simplicity itself. So this is saying that it's 2.5 by 2.5 arc minutes. So that sort of is in conflict with what Sinbad was saying. There's a lot of uncertainty in most astronomical stuff, for sure. Let's see, is there anything else interesting here about this guy? There's images, there's references. Detailed chemical abundance from co-added medium resolution spectra. Yeah, it's not too interesting. Here's a 1943 Astrophysical Journal paper on two objects, NGC 5053 and NGC 6838, which is M71. Let's just look here. See, can we ADS abstract? So we can go to ADS, which is the Astronomical Data Service, and we can pull up the actual refereed article. See, you don't need a telescope to do research at all. Okay, so James Cuffey, 1943, Astronomical Journal. NGC 5053 and 6838 are remarkable for their structural peculiarities. The former is a well-resolved globular cluster, and the latter is a highly condensed. Oh, see, now they're calling M71 an open cluster, just a very, very dense one. Interesting. Let's see if they have any. You know, I'm always a sucker for pictures. So hey, why isn't this moving on? Come on. Looks like it's maybe just a really short paper. Just a really short paper? No, it's 5 pages. What the heck? What the heck? Taxing my my poor laptop, I think. Come on, we want to see pictures. I don't know why that's not scrolling around. Okay. Color magnitude diagrams. Someday we'll have to talk about how to interpret color magnitude diagrams. Those are really, really cool. That gives you a lot of information about sort of the population of the stars in the cluster itself. And the neat thing about looking at populations of stars in clusters is that you can sort of make the assumption that all the stars are the same age. Now that may or may not be true, but you can start with that assumption and see if you can find any relationships at all. Anyway, that's a nice old paper. Very, very cool. I don't know why I'm having so much trouble scrolling around on this. But let's just sort of see. Figure 2, so 6838 in long exposures. Whoop. Dang it. And I know I'm going over time here. So 6838 long exposures appear to be rich in faint stars and possesses a definite congested but probably resolvable nucleus. The surrounding region also is resplendent with faint stars. The cluster, while itself very well defined, may be in reality a condensation of a rich Milky Way star cloud. So at that time, they were counting about 3,500 stars in that cluster. I'll bet you that number has gone up. Bet you that number has definitely gone up. The distance, they say, is about 4,000 parsecs. So that actually coincides exactly with what Ned was saying. Clusters linear diameter, so how far across it is like 28 parsecs across. So what is that? 28 times 3.26 light years. So it's about 91 light years across. So in this image, right, if you look at this picture, let's go back to this one, because this one was really cool, the Sinbad one. And then I'm going to get out of here because I know I respect all of your time, and definitely want to talk astronomy for a good hour, and don't really like to go too much over because I know that time is precious. So what they're saying is that it's kind of hard to tell, right? But going from here to maybe here or so is 91 light years. So it takes light 91 years to go from here across to there. So that's pretty amazing. Pretty amazing. Through space density, and that's it. Really, really short paper. All right, well, cool. I'm gonna go back and stop sharing my screen. I'm gonna go back here. Another really strange thing that happened last night. I don't know if it's because of the cold. I mean, it does get cold here, but that's sort of relative. It was probably in the high 30s, low 40s last night when I was out live streaming the moon. But my this webcam just sort of died. Either that or Google Hangouts wasn't able to talk to it. So I was, of course, alarmed because really, without this camera, this live stream isn't going to be happening. So I would have had to scramble to either find a new camera or just sort of go on a hiatus until I could find a camera. Cheers. Tom, I get dizzy thinking about it too. I go out under my sky here, which is extremely dark, and I look up and I start to think about my position, my orientation, and the sensation that I get for a while is a dizziness, because I realize that I'm looking at a huge distance, and relative to the galaxy, we're tilted, right? We're tilted off to the side, so we aren't even lined up with the galaxy. So we're on this tilt, we're spiraling around this star, spinning on an axis. It's extremely dizzying. It's extremely dizzying. So the only remedy for that is just don't think about it. Don't think about it. Just look at it, enjoy it, greatly appreciate it, and be humbled, because what an awesome thing to be able to be aware of this. It's incredibly awesome. I didn't know that we were moving so. Oh, Susan, you have no idea. You have no idea what and really none of us have any real concept of our emotion. But it's complicated. It's very complicated, and it's usually very, very fast. We are moving at an enormous speed relative to even the center of the Earth. Um, Not to mention the sun, not to mention the galaxy, not to mention the rest of the universe, right? We are moving just at insane velocities, insane. If it if we were able to feel that, it would drive us insane. So I'm really glad that the motion is so smooth, and um, we can't really tell because everything's so far away that it doesn't look like we're moving at all. But let me tell you, we are screaming. We are screaming at an enormous speed. Now that enormous speed isn't even close to the speed of light. Not even close. But it's still an enormous speed. And yeah, it makes you dizzy if you think about it. Yeah. Yeah, for sure. For sure. All right. I'm going to get out of here for tonight. Glad everybody could come in. Those of you who are coming in for the first time and enjoy the content here, please subscribe. You can set the notifications to let you know when I go live. But I do go live every single day at 2 hours UTC. Hit the thumbs up or the thumbs down. I'm interested in the absolute value of of your reaction, not necessarily if it's a positive reaction or a negative. I just like to have a reaction. Um, Make some comments if you like. I definitely read all of those, at least at the moment, because there aren't a lot of them, and I will respond to those when it's appropriate. As I said, get onto my Discord server. There's a link in the down in the description there as well, and share this video if you know anybody else who has any kind of interest in the science of astronomy, or just thinking about the universe and our place in it, thinking about stars, thinking about galaxies, talking about telescopes. Any astronomical topic is up for grabs, and we can talk about things at any level that you guys want. If you're new and have just some basic questions, I can definitely help out there. If you're a pro and want to talk about research that you've done, and get some good questions about the work you're doing, please come on. I definitely like to fill up panel here. I know that Tony with Deep Astronomy the other night was trying to attempt to communicate that to me, and thick head. But next time, Tony, I will catch you. And if anybody else wants to come in on the panel on this hangout, you can send me an email at cosmiclettuce@gmail.com, and when I go live, I can send you the link to the hangout, and you can join in. And that means I just don't have to talk as much. because I'm exhausted. Just tired of talking. So I'm going to get out of here. Thanks for coming in. Thanks for viewing. As I said, share this around. I want to talk astronomy, but I definitely would like the crowd to grow as much as it possibly can. And I think with time and persistence and with patience, that will happen, because I am definitely filling a little niche that isn't being filled at the moment, doing a daily show. There is so much to talk about in terms of astronomy that doing a daily show is easy. I don't feel any kind of, I mean, this is not work. This is what I'm going to do anyway. In the evenings, I'm sitting here thinking astronomy, doing my own work anyway. So why not? Why not, I thought, just open it up for an hour to the rest of the world, find some like-minded people who also share a passion, and think and talk astronomy for about an hour, hour and a half, whatever. Get off the TV, get off the news, and just focus in on the passion that sort of puts us in a different place for a while. I think that's awesome. That's very, very awesome. All right, I'm going to get out of here. I've said that 3 times now. I'm really going to go this time. So I will see you again in 22 hours and 39 minutes from right now. Okay, take care, peace, cheers, and all of that. Have a great evening, a great day, and I'll see you tomorrow. Bye.